Hello students, welcome to today's class of Theory of Machines. We are dealing with the analysis of brakes. In the previous videos we have already discussed the block brake and detailed analysis of single block brake. We also solved numerical problems on the single block brake. In analysis of single block brake, we discussed the forces that act on the block and the drum and also learned to take moment of these forces about the fulcrum point to calculate the braking torque and the force applied on the lever. The same concepts will be applied in the analysis of double block brake. So I hope you have gone through those previous videos so that you can understand today's lecture effectively. So let's start with the double block brake. So this is how the double block brake looks like. As you can see, there is a drum and around which two blocks are placed diametrically and symmetrically. Now why this arrangement is required? This is done to overcome the drawback of single block brake. As we saw in the single block brake, only a single block is pressed against the rotating drum, and so the force is applied only in one direction, right? So what happens to the drum in this situation? From free body diagram of the drum we see that there is an unbalanced normal radial force on the drum. Due to this unbalanced force, a side thrust on the bearing of the shaft supporting the drum will act, inducing bending stresses in the shaft. This produces the bending of the shaft, and this is not desirable. So to prevent this bending of the shaft caused due to the unbalanced normal radial force on the drum, two blocks are used on the two sides of the drum as shown here, so that they can nullify the effect of the unbalanced forces on the drum, as the normal radial force will act from both the sides of the drum, so they will nullify each other's effect and avoid the bending of the shaft. So as you can see the construction of the double block brake, observe that two levers with the block attached are placed diametrically and symmetrically on both sides of the drum. The two levers are pivoted at 2 points as shown here, and the two equal and opposite forces are applied at the free ends of the two levers to apply the brake and to stop the drum. Now there are so many ways in which the two equal and opposite forces can be applied on the lever. For now we are not much concerned about this, but generally a bell crank lever arrangement is used to apply two equal and opposite forces. Now let's see how this works. Let's see it once again. So this is how the forces are applied from both the sides on the drum to make it stop. So you can see here that the braking torque in case of double screw brake becomes 2 times as the torque is applied from both the sides. Now let's see the forces that will be acting on the drum and the block. So this is the drum and these are the two levers along with the blocks which are pivoted at O1 and O2. L is the length of the lever, or it is the distance of the fulcrum from the point at which the force is applied. A is the distance from the center point to the fulcrum. Now let's see the forces and try to draw the free body diagram. This is the drum which is rotating in the clockwise direction. So as discussed earlier in the case of single block brake, here there is a block and lever on the left side and there is a block and lever on the right side, and the force is applied from the left side also and the force is applied from the right side also. So there will be a normal radial force on the drum from the left side, which is N1, and as a reaction to this normal radial force there will be a normal reaction on the block as shown here. Similarly, there will be a normal radial force from the right side on the drum, and again as a reaction to this normal force there will be a normal reaction acting on the right side block as shown here, that is the force N2. So N1 and N2 are the normal reactions on the left side and the right side blocks. Now as the drum is rotating in the clockwise direction, so at this point on the left side of the drum, the velocity of the drum will be in this direction, in the upward direction. So the friction force will act in this direction, that means the downward direction. So this is how the friction force will act at this point if the drum is rotating in the clockwise direction as shown here. So F1 will be the frictional force on the left hand side. So an equal and opposite frictional force will be acting on the block as well. So this force is in the downward direction, so an equal and opposite force, that means in the upward direction as shown here, the friction force will be acting on the block, and it will be F1. Now similarly, at this point on the right side of the drum, the velocity of the drum will be in the downward direction, as you can see. So the friction force will be acting in the upward direction, that is the direction opposite to the motion of the drum. It will be like this. So F2 is the force of friction on the drum. So equal and opposite force of friction will be acting on the block on the right hand side. So the force of friction on the right hand side block will be in the downward direction as shown here, and it will be F2. So these are the forces acting on both the left side and the right side block when the drum will be rotating in the clockwise direction. Now what will be the braking torque in case of double block brake? So braking torque will be nothing but it will be the sum of the braking torques of both the levers. So TB will be equal to mu N1R plus mu N2R. Mu N1R is the torque applied by the left side lever, and mu N2R is the torque applied by the right side lever. So we can say that in case of double shoe brake, the torque becomes 2 times. So this is how you can see that what are the forces that will be acting and how we can calculate the braking torque. Now to calculate the value of N1 and N2, the same procedure should be applied as it was done in single block brake. That means we have to take moments about the fulcrum point. So to find out the value of N1, we should consider the free body diagram of the left side of the lever and take the moments about point O1. Similarly, to find N2, we should consider the free body diagram of the right side lever and take the moments about point O2, and then accordingly solve those equations to get N1 and N2. As this is already explained in case of single block brake, so we will not repeat it here. I hope you have seen the videos and you have understood the method of taking moments in case of single block brake. So in the similar manner, you can find out the value of N1 and N2. So hoping that you have understood, let's proceed with an example. In that example, again I will explain how to take the moments. So let's see the problem number 1. So the problem statement is like this. A spring operated pivot shoe brake shown in figure is used for a wheel diameter of 500 millimeter. The angle of contact is 90 degree and the coefficient of friction is 0.3. The force applied by the spring on each arm is 5 kN. Determine the brake torque on the wheel. So this is the configuration given. The radius is 250 mm. The force applied on both the ends is 5 kN, and the angle of contact is given 90 degree. That means it is greater than 60 degrees. So we have to find out the equivalent friction coefficient. The distance between the pivot points is given as 100 mm. L, the length of the lever or the distance between the point of application of the force to the fulcrum, is given as 1000 millimeter, and the distance from the central point to the fulcrum is given as 400. Note that the direction of rotation is not given. So we have to assume a direction of rotation. So let's proceed with the solution, and as usual we should write down what are the given parameters. Diameter of wheel is 0.5 meter, so the radius will be 0.25 meter. Force is 5 kN. Angle of contact is 90 degree. The length L is equal to 1000 millimeter and distance A is 400 millimeter. The friction coefficient is 0.3 and the distance between the pivots is 100 mm. And we have to find the braking torque TB. So let us proceed with drawing the free body diagram and the forces that will be acting on the block and the drum. So this is the drum of radius 250 mm, and these are the two levers and blocks placed, one on the left hand side and another on the right hand side. So we are taking one subscript as the left hand side and two subscript for the right hand side. Now we have assumed that the drum will be rotating in the clockwise direction. The two pivots are at a distance of 50 mm each from the central line. Now as the drum is rotating in the clockwise direction, and as discussed earlier, force on the block will be like this. There will be a normal reaction from the drum onto the left side block as shown here, that will be N1. Similarly, there will be a normal reaction from the drum onto the block on the right side, that is N2. As the drum is rotating clockwise direction, so the force of friction on the left hand side block will be in the upward direction as discussed earlier, and that will be F1, that is nothing but mu N1. And similarly, as the direction of rotation of the drum is clockwise, so the force of friction on the block on the right side will be in the downward direction as discussed earlier. So F2 will be equal to mu N2. So these are the forces. Now as the angle 2 theta is more than 60 degrees, so we have to calculate the equivalent friction coefficient. So let's do that. So we have assumed that the rotation is clockwise and we have shown the various forces, and now we know that mu dash is given by mu dash is equal to mu 4 sine theta divided by 2 theta plus sine 2 theta. So putting the values of mu and theta in this, we have mu dash is equal to mu is 0.3 into 4 into sine theta will be 45 degree, as 2 theta is 90 degree, and 2 theta here will be kept in the radian form, that is pi by 2. So this will compute to 0.33. So mu dash we have found out as 0.33. Now for the left hand side of the block, we'll take the moments about 0.01. So we'll consider the free body diagram of the left hand side and take the moments about 0.01. So the forces will be N1, F1 and 5 kN. Now N1 will rotate the lever in the anti-clockwise direction about the point O1. So the moment will be positive and the magnitude will be N1 into the perpendicular distance of line of action of N1 from the fulcrum point. So the perpendicular distance is 400. So N1 into 400 will be positive, and then you have F1. F1 will rotate the lever in the clockwise direction about this fulcrum point. So it will be a negative moment, and the magnitude will be F1 into the perpendicular distance of the line of action of the force of friction from the fulcrum point. Now as this figure is not drawn to the proper scale, I'll just explain you how this calculation of the distance of line of action of the force F1 and O1 will be done with a different figure. So this is the condition given. Now this diagram seems to be in the scale. This is 250 mm and this is 50 mm. This is the force F1 which is acting at this point, and we have to find the distance of the line of action of this force from this fulcrum point O1. So this is the line of action of the force F1 and we have to find this distance. So this will be nothing but from here to here, and this is the radius of the drum, that is 250 mm. This minus this distance 50. So this distance will be nothing but 250 minus 50 mm, that is 200 mm. I hope you have understood the distance of the line of action of the force of friction F1 from the fulcrum point. So let's get back to the problem. So the moment of F1 will be in the clockwise direction and it will be negative, and the magnitude will be F1 into 200 mm, that is 0.25 minus 0.05, and force 5 kN will again rotate the lever in the clockwise direction about this pivoted point. So the moment of 5 kN will be negative and the magnitude will be 5 into the perpendicular distance between the line of action of 5 kN and the fulcrum, that is nothing but 1000 mm. So 5 into 1 meter. So this is the equation of moment taken about point O1. So N1 into 0.4 meter, N1 into 0.4 meter minus F1. F1 is nothing but mu dash N1, so mu dash is 0.33, and N1 into the distance. We have just discussed the distance will be 250 mm minus 50 mm, that is 0.25 meter minus 0.05 meter. And also minus 5 kilonewton is there, so we have converted it to Newton, 5000 Newton into 1 meter. This is 1 meter. So from here we can calculate the value of N1. So N1 we have calculated as 14970 Newton. Now similarly for the right side block, we have to take moments about point O2 and consider the free body diagram of this right side lever. So the forces are N2, F2 and 5 kN. Now this N2 will be rotating the lever in the clockwise direction about this fulcrum point. So it will be negative moment and the magnitude will be N2 into this distance 400 mm, 0.4 meter. Similarly, F2 will also be rotating this lever in the clockwise direction about point O2. So magnitude will be again F2 into the distance 200 mm, that is 0.25 minus 0.05 meter. We have just discussed it. Next, this 5 kN will be rotating the lever in the anti-clockwise direction about this fulcrum point O2. So that moment will be positive and the magnitude will be 5 kilonewton into this distance. This is nothing but 1 meter. So the moment equation can be written as, for the right side of the block we have to take moments about 0.02 and the moment equation is minus n2 into 0.4 and minus f2 into 0.25 minus 0.5 meter and plus 5000 into 1. So these two are clockwise and this is anti-clockwise. So from here we can calculate the value of N2, which is nothing but 10730 Newton. So we have obtained the values of N1 and N2. Now we can calculate the maximum braking torque. So maximum braking torque will be nothing but the sum of the braking torques of these two, from the left side and from the right side. So it is given by TB is equal to mu dash N1 plus N2 into R. So putting the values we get TB as 0.33 into 14970 plus 10730 multiplied by our radius of the drum is 0.25 meter. So this gives us TB as the braking torque as 2120 Newton meter. So this is how you can do the analysis of double block brake. I hope you have understood the method of taking moment about 0.01 and 02 and then how to calculate the braking torque in case of double block brake. So this is all for today's lecture. In case of any doubt, please feel free to contact me. Thank you.